We got to go into the y equals, yes? Okay, so we're going to type in 1 plus 20t is the xt theta n, not an actual letter on your graphing calculator. So it'll show up as x, but it doesn't really matter. Now this one is actually subtract 5t squared. Okay, right here, this button right here. This button right here is the x. xt theta n. So in order for us to be on the same graphing window, we're going to go zoom 6 for zoom standard. Okay, so we can't see the entire graph. Okay, so does everybody see that this is a football being kicked vertically? So do we need to have any of the negative x's and negative y's? No. So let's go to our window and get rid of that. So we don't need to have negative 10. So let's just start at 0 and go up to 10. I think I saw the whole graph going on there. And then for the y's, I don't need to have that, but I didn't have it high enough. So instead of going up to 10, I might go up to 20 just to make sure. But I don't even know if that's going to be high enough. So let's go see if, oh, it looks like 21. So I'll go up to 25 then, just to be sure. So I'm going to go up to 25 and we'll see. So now I can actually see the whole entire parabola. So make a rough sketch of it. I have the luxury of just dragging it over. There we go. The rough sketch of the parabola. Okay. So how would I find where the football hits the ground? Does everybody see? This is the path of the football. The football hits the ground right there. What is that called on our graph? X-intercept. So we need to find our X-intercept. Now, if you have an iPad, it's pretty easy. You just touch the X-intercept and it'll tell you. For us on our graphing calculator, we need to go to, now the problem is it doesn't see the other end. So this is probably a little bit of a problem. I just need to go back to my window setting and make so that my Y has a little bit of negative so it can see the sign change. So just make this maybe -1 or something. Okay, so now I'm going to go to calculate. Which one of these selections would be my X-intercept? No, this says intersect. That's an intersection of two things, right? It's the 0. Yeah? Intercept is with a P. Intersect is with a C. Do you see the difference? Okay, 0 is our X-intercepts. Remember, there's 3 names for X-intercepts. What were they again? Zeros. Actually, 4, I guess. Roots. Solutions, yes. Okay, so I'm going to go to 2 for 0. And I need to go on the left and the right of that. So left bound, I got to find where. I can't even see where it is. So I'm going to keep on. No, I got to go left more this way. Do you see where the X-intercept is where Y is 0, right? So I can, oh, there it is. I can see it flashing now. So I have to press enter, and then I have to go on the other side of it and where it goes to the negative. There it's negative. In order for it to calculate the X-intercept, it has to see a sign change. So does everybody see it's 4.04939? Did you get that on your iPad? Okay, I'll help you in a second. I'm just going to write this down. So 4.04, actually 4 to the nearest tenth of a second, so second. Okay, so we can solve a quadratic equation of the form ax squared, that should have been a little 2, sorry about that, ax squared plus bx plus c equals 0 by graphing the corresponding quadratic function. What's the corresponding quadratic function? Well, it would be y equals ax squared plus bx plus c. What's the difference here? The y is 0. What's that called? When y is 0? The x-intercepts, or the solutions to a quadratic equation are called the roots of the equation. You can find the roots of the quadratic equation by determining the x-intercepts with a p or zeros of the corresponding quadratic function. So that's what we actually did. Okay, so do you see this negative x squared plus 8x minus 16? What are we going to punch into our calculator in order to find the roots? We're going to punch in y, or y1. I'm going to do the graphing calculator punches. y1 equals negative x squared plus 8x minus 16. And how do I correspond that y is 0? What do I do to figure that out? I calculate the x-intercepts, or the zeros. Okay, so let's do that. And the thing that you have to remember about the graphing calculator is very finicky between what the negative is and what a subtraction sign is. Is this a subtraction sign in front of the x squared? No, it's a negative. So make sure you use the negative that's underneath the 3. So negative x squared plus 8x, subtract. That's the subtraction button, 16. Now, for us all to have the same graphing window, again, we're going to do zoom 6. Zoom 6. Zoom 6. Did everybody get zoom 6? Okay, so I'm just going to put this over here. Can you remember how to find the zeros? Can you remember how to find the zeros? Okay, how do we find it? We go to calculate, we go to 0, and we tell the calculator to go. I know the 0 is right there, so I have to be on the left of that. Am I on the left of that? No, I have to keep on. There we are. Now I can see I'm on the left of that 0. Does everybody see? Then I press enter. Then I go on the right of that 0, so on the other side. Doesn't matter where. Then press enter. Then you guess. Who cares? What's your 0? 3.999978. Now mine came on a pixel that yours would say. The iPad's actually said 40. The correct answer is actually 40. For some reason mine picked as pixel. Did the other people's too? You have 4.00. It, for some reason, it takes it's a pixel off, right? So anyways, you should get that x is 4. So x equals 4. That's what that is right there. Okay, try the next one. In order to calculate the zeros, you must be able to see the zeros. So sometimes your viewing window might not show everything. So do B, and I'll give you a second to try it. Okay, so if I want to graph this, I'm going to go to my y equals. I'm going to punch in 100 plus 15x subtract x squared. And I'm just going to zoom 6 to start again. And the thing is I don't even see the other part of it. So now I have to start playing around. It looks like this part is 1, 2, 3, 4, 5. So maybe in my window for my x, I only need to go as far as, say, -10. Well, that was -10. But I got to go way farther on my right side. So at this point, you could zoom out and try to guess, or I'm just going to make this 100 and see if that's enough. That might be way too much. Same with the y min. I can't remember what it looked like, but there was not enough to see the max, so maybe I'm going to do 100 there. and see how that works for me. Okay, so it worked a lot better. I don't need as much on this side, so I'm going to get rid of that. Okay, and then I need to go higher. Does everybody see? So on the right side, I'm going to maybe do this to 20. Hopefully that's enough. And then my Y max, maybe 150. Let's see. It's just about there. So this I cut off too much, and this I have to go a little bit more. Okay, so I'm going to go 25 and 175. Is that enough? Okay, so now I can actually see the full parabola. Now I can actually calculate. I'm going to calculate this one right here. So I'm going to calculate the 0 there, which is number 2. I'm going to go on the left side. So do you see I got to go on the left of that 0. The problem is you can't really see where it is, but I know if my Y is in negative territory, then I'm on the left side. On the right side, I just have to be above that where the Y is positive. It has to be able to see a sign change, and I get 5, 0, which means my X is 5. Sorry, it is negative 5. That was my mistake. Negative 5. And what's the other side? I got to go to the other side, so calculate 0. Go on the other side. Like technically I could actually press enter at this point because it is on the left side, but I'm just going to get closer to where that 0 is. Notice when I press enter, an arrow shows up. That means it's calculating with between the arrows. So now I got to go to the other side. I just got to make sure my Y's are in the negatives. Oh, I went too far. What was it? 20, right? It was 20?
Yeah.
Okay, for the next one, does everybody see that you have to move the 2 over to the other side? Because in order to calculate zeros, the Y has to be 0. So we need to move that to the other side. So it's 2x squared plus x plus 2 equals 0. So we are going to graph Y equals, I'll clear it, 2x squared plus x plus 2. And I'm going to go zoom 6 to go back to my standard viewing window. And you can see the parabola looks like this. So what does that mean? How can I calculate a 0? You can't. So what does that mean? There's no X-intercept, so that means there is no solution. Because there is no X-intercepts, right? Okay, moving on. The graph of a quadratic function can have 0, 1, or 2 X-intercepts. Does that make sense to you that it has 0, 1, or 2? Here's a visual of 0, 1, or 2. We also did that when we did the graphing calculator stuff. Therefore, a quadratic function has 0, 1, or 2 real zeros, and correspondingly, the quadratic function has 0, 1, or 2 real roots. It's all the same thing. So you have to have your lingo all intertwined there. So this is a visual of the graphs. They don't have to all open up, of course, right? In order to have no X-intercepts or no solutions, you would have a thing opening down, a quadratic opening down, right, below the x-axis. For one X-intercept, if it was opening down, we saw that, I think, on the other one where it opened like this, right? And just hit the x-axis once. And then for 2, as long as it hit the x-axis twice, it's all good. Okay, moving along. A truck was traveling 23 meters per second. It decelerated for 15 seconds. The distance traveled by the truck, d meters, during this time is given by d equals 23t minus 0.6 t squared. Where t is the time in seconds. How long did it take the truck to travel? 60 meters. Okay, so I'll give you a second to see if you can figure that out. So y equals 23t subtract 0.6t squared.
I don't know. Is it really that big?
So again, the iPad's easy because you can just start stretching until it fits. For us, we need to, it's way up there. Is it that stretch up? It goes up to 250. So we're gonna go to our window and let's do -5 to 250. And oh, sorry, that was my y values. Try again, -5 to 250. And what was my x's that I had to have? So let's go from -5 to 50 for our x's to be able to see it good. So there we go. Does anybody need to see my windows again? Okay. And the question is how am I going to find, if this is a D versus T graph, what's the D, the Y or the X? Time is the X and D is my distance. So I need to find where the distance is what? 60. How would I be able to find where it's 60 on here? Huh? I'm sorry? No, the vertex is going to tell me the max. It might end up being 60, but I don't know that for sure. How can I tell where the y value, remember my y value is going from -5 to 250? So somewhere in here is 60, probably in 2 spots, right? So how would I find that? Well, I'm going to show you. Okay, so what you do is, because we're given a y value, type in the y value into y2. So y2 equals 60. And then you can see exactly where on the graphing calculator it hits 60. Right there and right there. Do you see what I'm saying? So how would I be able to figure out exactly where it's 60? The intercept with a C. So that is number 5. So I have to just kind of get close to the intersection because I have 2 intersections. The calculator won't know where to go. So I'm just going to get pretty close to that. Whoops, I went too far. My calculator went a little crazy. You know, just a little bit close to it. Press enter. On the second curve, it automatically jumps to the line. So press enter, enter, and it'll automatically find it. It's at 2.815.
Yep.
Okay, so I'm going to write that down. 2.815 seconds. And where's the other one? I need to go on the other side. So calculate, intersect, go way closer to that one. $35.517. Yeah? Or 518? Is that what yours said? Okay. Okay, let's do the next one. The curve of a suspension bridge cable attached between tops of 2 towers can be modeled by the function h of d equals 0.0025 d minus 100 squared minus 10, where h is the vertical distance from the top of the tower to the cable and d is the horizontal distance from the left of the bridge, both in meters. What is the horizontal distance between, I like my word there, what is the horizontal distance between the 2 towers? Express your answer to the nearest tenth of a meter. So just so you know, we're going to graph this and then we're going to compare it to the picture so you know what you're looking for here, okay? So again, we're going to go to y equals, we're going to clear this stuff out of there. 0.0025 bracket x, subtract 100 squared minus 10. So subtract 10. I'm going to go to zoom 6 just to see what this is going to look like, and I don't see anything. So here's a clue of what's going to happen here. What's my vertex? 100, negative 10. Is this a minimum or a maximum? It's a minimum. So at 100, negative 10, I'm at a minimum. So that should give me some, so first off, let's go from, say, 0 to, it has to go 100 over. So let's go 200 over. And then for my y, it was negative 10, so I probably need to go a little bit, well, I can go negative 15. Let's see if that gives me a better picture of it. Look at that. Okay, I'll show you my window settings. Okay, so now we're going to look at my graph and compare it to this. So how am I going to figure out the horizontal distance between? Does everybody see that this right here and this right here is this part of the graph? Look, I'm going to take this out so you can compare it. Does everybody see? Look at this comparison. I'll make it a little bit, actually it'd be more like this, right? Does everybody see that? That's more like that. Okay, so what's this horizontal distance between these two? How would I figure out? Well, I'll compare it to here. What's that starting spot called? A 0. So we can call that 0, 1. And what's that one called? Say 0, 2. And how are we going to find the distance between? Yeah, subtract. Okay, so let's calculate it. Calculate 0. Again, you have to be on the left. They have to see a sign change. So a left. Because when I hold it, sometimes it just goes, like right now, it keeps on going. And then I can't stop it, and it's already at whatever. There. Okay, did you get 36.754? 36.754, and that would be, say, it doesn't say meters. We'll say it's in meters. And the second one, I know you guys in the iPads have it so much faster. Let's try again. Okay. My finger is getting sore from tapping this. Watch what happens when I hold it. Look at it's just gonna go and go and go and go. This is why I don't do it and I don't listen to people. Okay, did you get 163 by 163.246? What did I say? 163.246. How do I find the distance? Equals 163.246, subtract 36.74, and what do I get as my final answer? 126.492, and that would be meters. What do you think about that?